Yo, what's going on, everybody? Happy Friday. Hope everyone's having a great day today. We are about to dive back into some more game development, just like yesterday. Fixing up a few things and continuing development on Midnight Sun. So let's get into it. Yeah. Now, let's see, where was I yesterday? I think I left off working on the save system, and I had a few things to check off this morning, which I actually did a few already. One of them was working with the encryption stuff, because we found that was broken yesterday. So I went ahead and made some updates already this morning, and we're going to test it out really quick. Encryption test. So project, scripts, core, and we'll make a new mono behavior, call it encryption test. So my encryption system works off an interface. I then have an abstract scriptable object for creating scriptable object versions of encryption. And then I have an AES encryption class that handles all the encryption and decryption for me. And the AES encryption scriptable object just has a read-only AES encryption object in it and delegates its methods to that object. So that's kind of how that works. And we can run through the encryption as well. So I actually had some older code in here and I had to clean it up a bit. So how the AES encryption works is the Advanced Encryption Standard Security Algorithm. It takes in an input string, and it can take in a key and an IV that's like a hash and a salt for encryption. And this is just if you have your own key and IV for your game that you want to use, then you can pass those in. And the very first thing we do is create a new AES object. And if the key that you passed in, yo, what's up, Memo? How's your Friday going? Happy Friday. And if you pass in a empty key, the AES object will generate a new key for you. Otherwise, if this key that you pass in is not empty, we will use the UTF-8 encoding and get the bytes from that key that you passed in. Actually, that might not be right. This might need to be a byte array now. Going all right, have a meeting in 15, but after that I should be done for the day. Awesome, nice. I hope your meeting goes good, sir. I'm fixing up the encryption today, so I'm just kind of talking through it. And one thing I forgot. So I have this encryption result class that I return. And I actually want to make the key and the IV a string. So when we return these, we want to do the same thing, is convert that to a base 64 string. That way we get the string version of these byte arrays, right? These are all byte arrays. So how the encryption works, let's start over. It takes in an input string and an optional secret key and initialization vector, or IV for short. We create a new AES object. If the key that you passed in is empty or null, we will generate the secret key for you. And if the key that you pass in is not empty or null, we will use UTF-8 encoding to get the bytes from that key. Same with the initialization vector. If the one you pass in is empty or null, we will generate a random one for you. And if not, then we will get back, or we will get the bytes of the one that you passed in using UTF-8 encoding. Then we do the same thing. We use UTF-8 encoding to get the bytes of the input string. And using an AES encryptor, well, we use the AES object to create an encryptor. That's this guy. It's an iCryptoTransform interface. And then we use that encryptor to transform the input bytes from the offset of 0 to the length of the bytes. That just means encode the whole thing. We could actually encode just a piece of it if we want, but that doesn't really make sense. Or it could make sense in other cases, but not in my case. And then last but not least, we return a new encryption result object that takes that encrypted byte array and converts it to a base 64 string. And then same with the key and the IV. We return those to you because if you did not pass in a key or an IV and they were generated for you, we need to return those back to you so that you can actually decrypt. Because without those keys, you won't be able to decrypt properly. Now, the decryption works exactly the same. We take in the encrypted string, and we convert that encrypted string back to a byte array. So we go convert.from base 64 string and pass in that encrypted string to get the encrypted bytes. We create another new AES object. We take the key and the initialization vector that you've passed in, and we get the byte array. We set the key and the IV on the AES object to the UTF-8 encoded byte array from the key and the IV that you pass in. If you forget to pass those in, they will just be empty, and you would then get back an empty result, which you don't want. Then we create a new decryptor using that key and IV, and we use that decryptor to transform the final block of the encrypted bytes. And same thing, just input offset of 0 and encrypted bytes.length. That would be if we want to just encode or decode part of the string. And last but not least, we take that decrypted byte array and convert it back to a string using UTF-8 encoding. And that is how our encryption works. So, in fact, let me add my copyright up here, just because this is my company's code. And let me build that. I think I did already, but just in case. Oh, I guess I did have some changes. And let's go ahead and get back into the Dark Matter Studios Unity project, and we're going to test it out, make sure that it actually works how we want it to. And then from here, once it's working, we can go back into the Midnight Sun project, as we were trying to do yesterday, and we can turn back on the compression and encryption and actually see that in action. So I have this encryption test object. So what I do in my Dark Matter Studios project, I have a test object, which for some reason has an audio source on it. I don't know why. It's not supposed to. An empty test object, and then underneath it I kind of put all these different tests of things that I've worked with. Apparently that's missing the cutscene player. Anyways, that doesn't matter. So these are just different mono behavior test classes that I've scripted in this project only. And the one we are working with is the encryption test. And that's just an empty class at the moment. So we are going to go ahead once Rider catches up here, starting the ReSharper engine. But we're going to go ahead and work with our AES encryption scriptable object and just make sure that it is encrypting and decrypting like we want it to. All right, so we'll create a, not serializable, but a serialized field. This will be an encryption SO, so an encryption scriptable object. Technically, we could use any encryption scriptable object, and we're going to use the AES implementation because that is kind of the industry standard of encryption at the moment. Script bail. Script bowl object. Awesome. Now, we're also going to want a string to encrypt. We'll call this input. The string to encrypt. All right. And then, let's see. Is there a way to make a serialized field read-only? Uneditable unity. No, that's not what I'm looking for. Accessible within the editor, blah, 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 blah. I think I have to create a custom inspector for that, and I don't want to do that, really. Yeah, but I think actually I have... Did I create a read-only attribute? I thought I had at some point. Anyways, that doesn't matter. And then we're gonna do this. Just so we can see it here. In fact, we'll make another one up here for the dependencies. And why isn't... Are we still... Why isn't it like syntax highlighting? Come on, Rider, catch up. Anyways, let's make a... basically, we just want to take this, put it there, and we will call it output. The encrypted output string. And the reason we did this is just so that we can see it in the inspector. We will also log to the console for this. Public void encrypt. So we'll take the encryption SO. We will encrypt the input string. And we won't pass in a hash or anything. What we'll do is we will store those here. String IV. That way they're not shown as it should be. They should be nice and private and not accessible by anyone. And so we'll say var encryption result equals that. And then we will set the key equals the encryption result key, and the IV equals the encryption result IV. And then we will give this a context menu called encrypt. So we can just do all this in the editor. And then we'll do the same thing, except we'll say this is the output equals decrypt. No, sorry. We want to take the... maybe we'll make a second variable here. So this is going to be encrypted output. And get rid of that formerly serialized as. And this will be the decrypted output. That way we can see what the original input was and see if it then matches the decrypted output. For sure. Have a good meeting, bro. See you in a bit. So encrypted output. Encrypted output equals the encryption result value. Boom. And the decrypted output will be the encrypted output, and the key and IV that we used. And we don't need that. Now, maybe let's do some validation here. If the string is null or white space, encrypted output, or the string dot is null or white space for the key, or string dot is null or white space for the IV. We'll do a debug log, nothing to decrypt. In fact, we'll do it like this. We'll make sure each and every one is separate, just because we want to know exactly why it's not decrypting. So let's get rid of, actually we just need two. Just do it like that. No key or IV to decrypt with. Boom. Alright, so that's kind of our validation for decryption, and let's make sure this is actually called decrypt. And let's also do the same for encryption. If the string is null or white space of the input, then there's nothing to encrypt. And that's really the only thing we need. So now every time we encrypt, we should probably return too, actually. Return. And return, because we don't want to actually try to decrypt anything. We would just get back an empty string anyway, not a huge deal. Alright, so we have our encrypt method and our decrypt method, and the last thing I want to do is, before we actually encrypt anything, we want to set the encrypted output to an empty string, and the decrypted output to an empty string, and same with the key, and same with the IV. That way, if we have any results in there from like another, from something else that we tried to encrypt, so like the first time around, we will encrypt the input, and then if we tell it to encrypt the input again, we want to clear these out because maybe we changed the input. So that'll kind of just clean things up for us. And that should really be all we need to test out that encryption is working. So let's go test it out. Alright, so we will select our AES encryption scriptable object, and this is a test for encryption. So this is our test string that we're going to try to encrypt. And if we right click on the script and hit encrypt, we should get an encrypted output. And then if we right click again and decrypt, we should be able to decrypt whatever gets set in here. And that should then show up here and match this input exactly. So let's try it. We encrypt. Perfect. We've taken this string, we encrypted it to a random gibberish encryption string. And now if we decrypt, ooh, decrypt did not work. We didn't get any error either. So it tried to decrypt. So we can, in fact, encrypt, but now, did I set that up right? Yeah, encrypted output. We're taking the encrypted output, and then we're decrypting it and setting it to the decrypted output. So we got encryption working, but we do not have decryption working. We got to go figure that out. So let's jump back into our AES encryption here. Now this method is working fine. This method is not working fine. So let's see. It's pretty straightforward actually. I just ran through it a second ago. So that is strange. And we're not getting any exception or anything. In fact, why don't we breakpoint this? We'll attach it to the Dark Matter Studios editor. Enable debugging. And let's run that decrypt again, and then we can kind of follow through the breakpoint and see what's going on and where in the process of decryption it is failing. So we're pretty close here. I got it halfway working. So if we decrypt, we're going to hit this breakpoint. The encrypted, here's that encryption string that we have. And this would be null because we haven't gone past this line yet. So let's step over that line. We now have the encrypted byte array. Let's go ahead and step over that. The key that we're passing in is there. So let's step over that. Oh, it is hitting an exception actually. When trying to set the key, we're getting an error. Can we see what it is? Specified key is not a valid size for this algorithm. Interesting, because we actually had it generate that for us. Huh. How could it not be a valid size if it literally generated it for us? Spectric algorithm set key. Yeah, so it's just saying, and it's not writing to the console either, which would be nice if it did. And then it's returning an empty string. Interesting. Okay, so setting the key is not working, which means it also won't work up here when we set the key for encryption. Let's look up this exception really quick. It's the cryptographic exception. Is there not a set key that I thought? Interesting. So how to set key? So we already kind of know this. Yeah, so we're doing all that. Require a key and a new IV to encrypt and decrypt data automatically created. Oh, I didn't realize that it was actually automatically created when we create a new instance. So technically, we don't need this generate here because when we're creating it, it's already generating these for us. So instead, we'll just say if it's not null or white space, then set it to this key that we've passed in instead. And same here. Now we know that something's failing with getting the bytes of this key. So this key is a byte array that is generated for us. And we then return it as a string. And maybe that's the problem. Maybe I'm not converting it to the right type. Or maybe I shouldn't convert it at all, but I would like for it to be returned as a string. And then when we pass it back in, we're trying to then get the bytes from it, which in theory shouldn't have a problem. It should give us back whatever it was originally, and then use it for decryption. But I have a feeling that might be where the problem is. So let's keep reading here. What is the difference between symmetric versus asymmetric? Uses the same key for encryption and decryption, while asymmetric encryption uses two different keys, a public key for encryption and a private key for decryption. Maybe I want the asymmetric, because then I always have the decryption key, and I can just generate new random keys for encryption every time. You don't have to pass that in. Interesting. So you know what? I'm gonna ask ChatGPT something here. stay logged out. This is my AES encryption code. The AES key and IV are byte arrays, and I want to return them as strings. Then I can pass them into my decrypt method to decrypt something. Does my code look correct, or what can I change? Let me be more specific. Right now, the encrypt method is working fine and returns back an encryption result object that just contains the encrypted string, and it just returns back the string, key, and IV as back the encrypted value, key, and IV as strings. In the decryption, or the decrypt method, when trying to set the key, oh, you know what? I wonder if it's because it needs to be passed in here. No, you definitely need to just set it. So in the decrypt method, when trying to set the key and IV, I receive a cryptographic exception because the key is not the right size. I take in the base 64 string of the key and IV, but when trying to set the key and IV on the AES object, I receive a cryptographic exception because the key is not the right size. Does my code look correct, or what can I change to fix this issue? And then let's give it the code. And let's see what ChatGPT has to say, huh? So the issue you're encountering stems from the way you handle the key and IV in your AES encryption and decryption methods. Let's address the problems and suggest improvements. Encoding issue. The key and IV should be byte arrays of specific sizes for AES encryption. 128, 192, or 256 bits. Yes, I know that. Encoding them as UTF-8 strings can lead to issues, so I thought it had something to do with that, because the byte representation of UTF-8 can vary based on the characters in the string. So key and IV size. AES expects specific sizes for key and IV. So either 16, 24, or 32, which represents 128 bits, 192 bits, or 256 bits for maximum encryption protection. And the initialization vector is always 16 bytes. Base 64 representation. While converting the key and IV to base 64 strings for storage or transmission is common, decoding these strings back into byte arrays before setting them in AES is crucial. I am doing that. Did I not? To convert to... So here are some adjustments to ensure proper handling. In the encrypt method, encode the key and IV as base 64 strings before returning them in the encryption result. That's exactly what I'm doing. Hello, convert to base 64 string, right? What did you change in my code, ChatGPT? You fail. Decrypt method, convert from base 64 string. Am I not doing that? Oh, no, I'm just getting bytes. Oh, gotcha. So I understand what I did wrong. Convert from base 64 string the key, and same with the IV. That should fix that, and then also do it down here. And that should fix our issue. Yeah, everything else is the same. Now, how can I... I'm curious on something. AES.generate key. Can we tell it what size to use? Yeah, I didn't think so. So how do we tell it what size to use? How to determine AES key size, C#. So I guess there's a key size integer. So do we want to pass that in? Key size? No, that's not what I was looking to do. Oops. Add the XML documents, the encryption key size, i.e., what was it? 128, 192, or 256 bits. Or 256 bits. And we'll say this is an optional encryption key size. Now I'm confused here because maybe we'll put this at the end. No, because maybe I'll make a second method then for that. But I was going to set it to a default value of, I guess let's just use 128 for now. That way, we create the new... now, how do we actually set the key size after creating it? Do we have to say key size equals key size? But will that, since they're already generated here, will this regenerate them if it's a different size than what was standard? Let's go into their code actually. So I think they just use 256 by default. So let's not even pass that in because it's already going to be the most secure that it can be by default, technically. So that way they're generated fine. If the key that you passed in is not empty or null or white space, then we will convert from the base 64 string of it. Now, do we also want to do the same thing here? Should we convert from a base 64 string the input to get the byte array? I think we should, just to match everything. Then convert from base 64 string. So we were already doing that, and we just needed to do it for the key in IV. So there we go. All right. I think we are all good now. We'll stop and build and go back into the Unity Dark Matter Studios project. All right, and now if we decrypt, we get back the same exact result that we put in for encryption. Perfect. Everything is working as expected. Let's update this to something else. Dark Matter Studios is awesome. Let's go ahead and encrypt that. Ooh, that's not working. Now, I have a feeling that has something to do with how I changed this from encoding.utf8.getBytes of the input. I think that's what we want to do. All right. All right, so if we encrypt the string, we then get an encrypted string of Dark Matter Studios is awesome. And if we decrypt, we get back the same value. Perfect, we have fixed encryption. All right. Why am I missing encryption settings? Because it's broken. Gotcha. So let's make this encryption settings scriptable object. And put that to normal. No, that was not the right object to make. I said encryption settings scriptable object. There we go. And as you can see, it generates a hash and salt for us. Now, do I want... first off, this should be called key. That doesn't matter. The encryption key, and this will be called IV for initialization vector. And that doesn't matter. Get rid of that unused using statement. Yo, welcome back, Memo. I got the, I got it figured out. I'm just working on the encryption settings, but here, let me show you here. We have this encryption test, and we're gonna go ahead and change this input value to memo is awesome. And if we right click and encrypt, it has taken this input string of memo is awesome and encrypted it to this random gibberish encryption string. And then now, with this filled in, if we right click and decrypt, the decrypted output should match the input. So we right click decrypt and we get back memo is awesome. Yeah. So we now have the AES encryption working at full security with 256-bit key. So now I have this encryption settings scriptable object that you can create for your project. Yeah, sick. And before I was generating a random string for the key in IV for this scriptable object based on these allowed characters. I don't think I actually need to do that anymore. Instead, I think what we want to do is say using, we actually don't need any of that. We can use the new one. AES equals AES dot create using var AES, that is. And then right here, the key equals AES dot generate key oh, no, hold on. Generate should actually go on its own line. And then we want to convert dot to a base 64 string, the AES dot key. So whenever you generate a random key, it'll create a new AES object, generate a key, and then convert it to a base 64 string and put it in the field for you. And then we want to do the same thing for the IV, the initialization vector. So we'll just copy and paste that code. We'll make this IV AES.IV, and we will generate an IV. And that will then generate random stuff for you. Now, this is all using symmetric encryption, which I just learned about, which I kind of already knew, but I didn't really, well, I did understand the difference between symmetric and asymmetric, but I had to look it up to confirm what I understood. Symmetric encryption uses, when you encrypt something, you have to then use the same key and IV to decrypt it. Asymmetric can use a different key and IV every time for encryption, which makes it more secure, and then uses a different key from those values, but you have to have that stored somewhere to then decrypt. So that's what I'm trying to figure out next, because I would prefer to do it that way. How to create an asymmetric encryption key, C#. So you have to have both the public and private key to implement asymmetric encryption. To encrypt data using asymmetric encryption, you first need to generate a public-private key pair. You can do this using the RSA algorithm as shown below. Let's actually go into here so we can see what he's talking about. That's all symmetric. There we go, implementing asymmetric. Can do this using the asymmetric algorithm as shown below. Okay, so this would be how we get our public and private key. So you can then use the public key to encrypt the data, but then to decrypt the data, you will need to use the private key, right? I don't know that I want to go that far yet. I do, but I don't. We can update that later. The point is, encryption is now working. Let's get out of here. We will build this. We got our encryption working. Let's get back in here. Because right now... No, I guess to make it more secure, whenever I encrypt something, I could have the encryption setting scriptable object. Where was that? Oh, this is not even the right project. The encryption setting scriptable object, instead of generating random keys and IVs, we could generate a public-private key pair and not ever show the private key. Maybe that's what we do. Hold on, I have an idea. Where was I? Let's go back to my history. Generating keys. No, that wasn't it. History. Symmetric, asymmetric. There we go. So we would want to... and we actually do it differently too. So, okay, so this is generate random key. Let's make sure that method name matches. And we'll make those var. And we'll just call that public key and private key. Now, do I want to convert it to an XML string? But do I have to use the RSA crypto provider instead of AES? That's what I'm confused on. Hold on, just getting some backyard notifications. There we go. Okay, we're good. Verify data hash. Oh, it's even got like a try encrypt. That's pretty cool, actually. Encryption with AES. I didn't specify C#. Oh, it does leverage AES. It's the same article, I think, right? Yeah, it is. So this does use AES. That is fine. Okay, so then we have a key would be why don't we actually just return? No, because then the context menu won't work. So we're gonna delete those. So you then don't actually need an IV anymore, or initialization vector. So we would just have the public encryption key, public key, and we'd have another string that is not shown in the editor. That will be a private key. So no one ever sees the private key, because you're allowed to see the public key. That's what's used for encryption. The private key is what's used for decryption, right? Technically, you could get the public or the private key. No, let's just rename it this way. Private key is the private key. No, I don't want to convert it to an auto property right now. We don't need that anymore. So now our public key equals that, and our private key equals that. Private keys. So generate random public private keys. We actually don't need that method. What I want is for this context menu to be here, and then we do that. And we'll call this generate random keys. All right, so then that generates it for us. We no longer need this. We no longer need this. It kind of does everything else for us inside of here. Now, the question is, in fact, we could actually change this to encryption keys SO. Holding the public and private encryption keys. Now, I don't even technically need to show the public key actually either. Let's also make that private. Get rid of all these extra using statements. And then they can be accessed. Can we actually make these internal? If we make them internal, then no one can publicly access these. The only person who can is someone from the same namespace, or in the same DLL library, that is. So we no longer need that. This should be public key. We no longer need that. This should be private key. And we actually don't need to return an encryption result anymore. That's a deprecated object now. We can just return the encrypted value. Let's make sure the interface matches. So we'll have public key, private key, and then that's public key, that's private key, yeah, that's what I was trying to do. Public key, private key. So, because this is actually the industry standard is to use asymmetric encryption, I believe. Not that symmetric encryption is bad either, but I would prefer to follow the industry standard as much as possible here. So do like that. In fact, let's move these properties up here because I like to have private and public fields at the top, then properties, and then methods down at the bottom, even though this is all abstract. So this needs to return a string. This should be called public key. An optional public key to encrypt with. And we don't need the IV anymore. It should just be like that. And we'll update this in just a second. And we're actually just going to return the convert to base 64 of the encrypted value, right? That's all we need. And here we'll just return a string.empty. Now, same thing down here. Let's get rid of that. Let's make this private key, because you have to pass in the private key. The private key to decrypt with. We no longer have an IV, and this returns a string, a decrypted string. Wow, I can't spell apparently. Decrypted string. And this one returns a string, the encrypted string. And then I actually like this a lot better because we're not returning the hash and salt at all. Those are something that will be stored separately in this encryption keys SO. And then we can actually, hold on. We want to make sure these are internal, I think. And can we... interesting. So one thing I forgot is the base AES encryption class is not a scriptable object, so it's not going to be able to reference this scriptable object. Instead, let's take this code, let's move it out into an encryption keys class, make that its own thing, and do that. Get rid of all the scriptable object stuff. Encryption keys, not an SO. In fact, it doesn't even have that, but it should have this as public. Generate a random public / private key pair. And we'll add the using statement, and boom. All right, so now all of this lives in its own separate thing. The encryption keys SO actually then doesn't need any of this code. What it does need is the encryption keys. Encryption keys equals new encryption keys. And in fact, I think we can even make it read only. I don't even think we need to store those values here anymore. We just use the encryption keys dot public key and the encryption keys dot private key. Get the private encryption key. Just get the private key is fine. Get the public key, get the private key. All right, so, and it doesn't even have a reference to cryptography anymore because it's just a scriptable object wrapper around this other thing. And last but not least, we can then call encryption keys dot generate random keys right here. and that will then automatically update these keys for us. And because they're all internal, no one can ever publicly access them, which is amazing. In fact, I don't even know why I need this scriptable object to begin with. I can just use the base class. I technically don't ever need the scriptable object. Well, now I guess I created the scriptable object so that you could use this context menu to generate a random key value pair. But what I'd rather do is make a private constructor that does that for me. So anytime this class is created, it will generate random keys. Now, the problem here is that we need to keep this public and private key. It needs to be the same every time we open up the game. And that won't actually work if we are you know what we should do? See, this is going to get a little difficult. Maybe I shouldn't have gone down this road. Because the problem is, and that, well, for now, that needs to be public so that this guy doesn't complain. But the problem is, if this encryption keys class is created as a new object every time the game opens up, we will always have a different public key and private key. We actually don't want that. We want to be able to serialize and deserialize this class. So we have to make it serializable. And the reason why is because our AES encryption that will use this class should actually see if it has been serialized and saved to the device. And if not, then we will create new public-private key. If it has, we want to take that value and deserialize it back into what it was originally so that everything else can be decrypted properly. That is the problem. Did I just... Oh, no. In fact, let's just do it like this. We're going to make these set public key equals value. Do it with some nice lambda expression bodies. And the reason why is because we can take this value, we can then serialize it and save it to disk, and then when we load up next time, we can actually set that value if it exists. And again, we keep this internal though, so no one outside of this DLL library can actually do that. It can only be the AES encryption class that will be able to do that. And that's exactly what we want, because then no one else outside of this code can actually publicly access these values. So we'll say set private key equals value, and make that a nice expression-bodied lambda. Now, we still have and it's fine that when this object is first created, we generate random keys, because that might be needed. So it'll just generate them to begin with, but then if we already have them like saved off in player preferences or something, then we will then set the keys. So do you need to ever generate these again? No, you do not. So let's put that as a private method down here. In fact, I think we can make this internal too. And that's private completely. Then that's fine. That's perfect. All right, now this encryption key scriptable object, I don't actually think we need that anymore. We will rename this folder to keys. No, don't rename all this other random stuff. Why would I do that, writer? And the encryption keys is then no longer needed, other than let's put my copyright up here, and is a data object for holding the public and public and private encryption keys, and it's just called encryption keys. All right, so that class is done. Encryption scriptable object then doesn't even need that, so no one's ever going to see these ever. What we want it to do is we should have an encryption keys object in here equals new, and it can actually be read-only, make it even more secure, and then we just delegate to that. And technically, we don't even need that. We don't even need that. You don't ever have to pass that in. It should always just use whatever is already included in that object. So you just pass in what to encrypt or what to decrypt. And we'll call this encrypted input. Well, why not? Just to be specific here. Interface for implementing encryption. Cool. So that's good. Then AES encryption doesn't need a public key. We can get rid of that XML parameter. We don't need a private key either. We can get rid of that parameter. But at the bottom of the class, it should have an encryption keys object. Encryption keys equals new. And we'll also make that one read only. Now, here's what we want. Is in the constructor, we will do a player prefs get string, we're going to have a constant string called public key. Public key. And the same for a private key. I feel like I went down a huge rabbit hole here, but I actually wanted to do this and get all this working the right way. So that this will be awesome, actually. So var public key equals player prefs get string public key. Okay, and we'll do the same for var private key equals player prefs dot private key. And then if public key if not string dot is null or white space public key, then the encryption keys public key equals the public key value. And then same for the private key. Now, technically, because these are being saved to player prefs, they will be visible or accessible on a player's device. And if we really wanted to get fancy, we could actually, we can give it a default value too. It would then be the encryption keys public key and encryption keys dot private key. So if these do not exist, it will then set the default value, or it'll, I think that sets the default value, does it? So you try to get a string. Hold on, let me double check that it does that. Player prefs get string. It just says that it will return the default value. What I want to know is if I give it the default value, will it set it for me? Let's just be very explicit, just in case, because I don't know that it's actually going to set it for me. So we will do this. We're just going to try to get those keys. If it does not, if it is not null or white space, we take the key that we got and we set it to the encryption keys. Else player prefs dot set string of the public key to the encryption keys public key. So we're being very explicit that if this key does not exist, then please set that key to this value. And if we want to get really fancy, what I was saying is we could actually encrypt this public key separately with a random set of stuff. That way, if anyone were to ever access the player prefs, This wouldn't just be the public key, it would be an encrypted version of it if we really want to get fancy here. So we might build that in later. And then we're going to do the same thing here, except this is all with the private key, private key, private key, private key, private key. Boom. All right. So that way, when this object is created, it will handle all of that for us. Now, we want to do the same thing down in this well, technically, this does it for us because this is using an AES encryption that will then automatically get those keys for us. So we actually don't need to do this here. And we don't need those here. Is that right? That's right. Okay. Now we have to update all this. Question is, what was that code to actually encrypt the data now? So it'd be this. Encrypt data false. So we don't need any of that. We don't need that. All we really need is the RSA. And we get that by creating a new one. And that might not even need a using, no, it does need a using statement because then it gets disposed of. So in fact, maybe we should add the using there. That way, after it generates the random keys, it will then dispose of that RSA automatically. So we're using an RSA. We get the bytes of the input string. And we then want to encrypt those bytes. What is FOAEP? To perform direct RSA encryption using the OAEP padding, only available on a computer running Windows XP or later. Otherwise false to use PKCS padding. Gotcha. Well, we want to keep that false then. Do we have to pass in a value there? Yeah, we do. So we want to keep that false because then this encryption can work on any device, including like an Android phone, for example. So we'll just make that encrypted. And wow, look how much cleaner that code is too. We'll do it like that. So we create a new RSA. How do we set the key? RSA private key. I didn't think about this. So we have the RSA. Can we let's go look up this object really quick. because I want to initialize a new instance of it, but then set the keys on it. And I don't know that that's possible, actually. I think you have to create a new one every time. Sizes, gets the name of the signature algorithm. Yeah, I don't see a way. Could I, is there an import private key, maybe? Import private key, gotcha. So we could import a public key and we can import a private key. So that's how we would do that. Okay, so there is a way. There is a way. Import RSA public key. Now the question is, so we want to say convert XML you know what? Maybe we don't want to. No, we have to do it that way. So how to convert XML public key to bytes or byte array. Man, I went down a huge rabbit hole for this. I guess we just say encoding default get bytes. Is that right? I think that is correct. So we say encoding get the bytes of the encryption key's public key. And I think that's actually right. And then out var, what was that variable called? Bytes read. Now, why would I want bytes read? What is that going to do for me? When this method returns, contains a value that indicates the number of bytes read from the source. This parameter is treated as uninitialized. So why do I need it? We'll just call it bytes read, I guess. Boom. And we're not actually using that for anything. Cool. Now, same thing, but we want to import. Actually, we don't need to import the private key here. We just need to import the public key. The public key is used for encryption. The private key is used for decryption. So we want to do something similar here. Let's just copy this code. We want to do something similar, but just in reverse order. So we would create a new RSA. We would import the RSA private key, and we'll make sure that's the private key. Now bytes, let's decrypt that, keep that false. This is decrypted, and what we want to do is right here, the bytes should be convert from base 64 string, the encrypted value. That's how we get the bytes. Then we get the decrypted bytes and then we return the 2base64 string of the decrypted bytes. Beautiful. All right. Technically, that should work. I have no idea if it will or not, but we're gonna check it out anyway. This no longer needs a key, so it doesn't need to be passed in. Just make that a nice one line. This also no longer needs a key or IV, or a key or an IV. Make that nice one line, get rid of those XML parameters, and let's copy the XML documentation here and paste it here, because we already updated it down here. No reason to type it again. Boom. All right, so now we have a scriptable object that represents AES encryption that just uses a AES encryption object underneath the hood and delegates to that. And that object handles getting and setting the public and private keys on a user's device. Now, the question is, so what I could probably do better here is, one, when I'm setting these in the player prefs, I should probably encrypt them myself with some other public-private key pair. And two, I might not even want to put them in player prefs, just in case a user clears the data of their application, this public and private key would then not exist. And, well, I guess if they clear their data, they're going to clear all their save files anyway. So that's on them. And then if I were going to save to the cloud, I could send the public and private key to the cloud as well, to the server. Okay, so technically this all should work, I think. I'm hoping. If not, I just went down a really big rabbit hole to make asymmetric encryption, and it was not worth it. So let's go ahead and update our save system. We don't need the value there. I know, right? We'll see. If it works, it's gonna totally be worth it. If it doesn't work, then we just wasted a crap ton of time. So that will encrypt and decrypt. And I think that's good. Let's go test it out. Let's see how well we did here, if I actually understood the asymmetric encryption process. Now another thing is, we don't need this string and IV. Oh yeah, what do you got going on? What's your bug? Yeah, I feel that. Whenever I had a bug to figure out, it was stressful. Let's just return this here. Technically that doesn't matter. We could even encrypt a empty string if we needed to. And I don't know if we need to do that. And we don't need to check this anymore. Alright, technically that should all work. The only thing I'm thinking might happen is because I'm just doing this in the editor and not at runtime, I don't know that the object has been, the encryption keys object has been created. So let's type in a new string here. Encryption is a pain in the ass. Certain data isn't populating when I'm in a certain view. The project is Frankensteined like crazy, so it's difficult to figure out if it's the event system or something else. Yeah, that's rough. That's kind of like the other day when my custom editor wasn't working, and I was like banging my head against the wall, like, bro, why is this not working? All right, let's give it a test. Oh shit. Gotcha. So I can't get or set the string of the player prefs inside the Unity editor. I don't know that that will matter right now, just to test it, but that's a good point to note that if we are running this inside the editor, we need to save it to the editor player prefs instead. Where was I doing that? That's down here. Oh, and the other thing, no, yeah, just in here. So we have to do, in fact, I don't even know that I can do this inside the DLL, because this is then going to be a built dynamic library. I don't even know that the preprocessor in here will work because it's a dynamic library. But I guess we'll try it anyway. Why not? So we'll do all the same. I guess it will. It's already showing up like it would. So else if what's the code for this? I cannot remember at the moment. I have it here in my game manager. Let's just do if not Unity editor. If not Unity editor, do all that. Else we must be in the Unity editor. Why is it complaining? Oh, because I haven't put an end if. Yeah, duh. That would help. Okay, end if. Now it's not complaining. Now let's actually take all this out, just so we can get our autocomplete working, and then we're going to make this editor prefs. I think that's what it is. We can actually exit all of this, and Unity editor prefs. Yeah, it is editor prefs. I must just not be using the correct using statement. This is not going to work though. This class lives inside a library that can be built at runtime, or that will be included in the project at runtime. And if it then has a reference to the Unity editor library, I'm going to get errors because you cannot include that at runtime. So I guess let's just do, if not Unity Editor, then do this code, end if. I guess that'll just make the error go away. But the problem is, will we have... Now, see, maybe I just, instead of like generating these like this, maybe that's the problem. Why don't we cache the crypto service provider, call it RSA. I think we can even make it read-only. No, we cannot make it read-only, because then we can't actually make a new one. So we'll say RSA equals new RSA, and then we'll set the public and private keys, but then you have access to the RSA. But where do I give you access to the RSA? So internal. Why do I need this? Why was I just thinking I needed this? Let's think very carefully here. Because I was thinking of reusing the same RSA crypto service provider, but that's not really what's needed. What's needed is using the same public and private keys. So no, we don't need that. Let's just undo all of that for now. Well, I was thinking, because then that way it'll work in the editor, because we're then using the same RSA. We're not creating a new RSA to do encryption and decryption, because when we encrypt, it might use one RSA, and then when we decrypt, it might use another. And since we're trying to import the private key into the RSA that we create, that might not actually work, because we might not have a private key in the editor. So maybe we do need that. Whoops. Do that. Internal. RSA. And we'll just like RSA. And it's internal, that's fine. That way we can use the same one for encryption and decryption. So when we create actually, so then when we set the encryption, where did we do that? We're doing that in the AES encryption itself. So up here, when we want to import, so when we set the public key, we actually want to import the value that gets encoded. So if you try to set the public key, it takes that value, it encodes it to bytes, and it tries to then import it into the existing RSA. And I just want to call that RSA is fine. No, we'll call it RSA capitals. And we'll add that to to the abbreviations list. And that's just going to say never used and auto property. Cool. Okay. So then import public key. And then same thing when we import the private key, or when we try to set the private key, we want to import it into the RSA. In fact, we don't even need to generate random keys. We can just say, oh, we can move this up here, equals new, and then the public and private key is just doing this. So that's how you get the public key. So we get it from the RSA to XML string, and the private key we get from the RSA to XML string, but pass in true for include private parameters. And then this should be value that you tried to send in. And we then don't need any of that. And technically we don't need those either. Hey. And technically you don't even need to get these. You just need to be able to set them. No, you do need to be able to get them so that you can save them off, serialize them to player prefs or something. Okay, so that all looks correct. Get the RSA crypto service provider. What does RSA stand for? Just RSA algorithm, I guess, right? Yeah. Get the private key, get the public key. Okay, that all looks good to me. And now we're going to have the encryption just use this RSA object. Because then we're reusing the same instance every single time. But we can, if we want to, have a public void generate new keys. And all that will really do is RSA equals a new RSA. New encryption keys. And then so because we created a new RSA object, it will automatically create a new public-private key set. And when you then try to access those, it will then access that cached RSA value that was then recreated and give you the new public-private key. So just in case we ever want to generate new keys for some reason, we'll put the option down in there. So we should be done with that. In AES encryption, we should no longer need to do that. And we'll just say RSA equals encryption keys.rsa. That way we're grabbing the one that we've cached. All right, just checking out a text message here. Then when we, oh, that's the decrypt already. Then when we encrypt, we want to do the same thing. Var RSA should equal the encryption keys RSA. And technically, we could just take that and put it there. Just one less line. And same for that. Wow, that's a lot cleaner too. So when we create a new AES encryption, it will automatically create a new read-only encryption keys. If we're not in the Unity editor, we can try to get those keys from the player prefs, which is probably bad practice. We're just doing it like that for now. So the last thing to update here to do, don't use player prefs and encrypt the public / private keys when saving to device. Yo, what's up? I don't even know how to say that name. Soj10? SOJ10? How's your day going? Happy Friday. Beautiful day today. I hope you are also having a wonderful day. Yeah, I do make games. I've been working in the game industry for quite some time, and now I'm trying to do my own indie stuff. And what this is kind of all the tools that I've created for my studio, Dark Matter Studios. And we're specifically working on an encryption and decryption algorithm right now for when we save data in a game. So to do, don't use player prefs, and let's make that again. Encrypt the public-private keys when saving to a device. So we will update that at a later point, but let's just make sure all this actually works now. And we'll go in here. We actually have not tested this yet, and I might have gone down a huge rabbit hole updating this to asymmetric encryption for absolutely no reason. And I hope that's not the case. So that is still being called, even though we're in the Unity editor. It should not be being called, but that's fine. So encryption is a pain in the ass. Let's try to encrypt that. Oh, I think I know why. Why is... AES encryption.so. Yeah, so I guess that's not, oops. So the problem is I'm trying to do this in the editor, and this would probably work at runtime, but it's probably not going to work in the editor. So what we'll do is, to make sure it works in the editor, we will check if this object is null or not, and make it not read-only. So if it's already created, then we're good, we have it. But if not, if we're trying to run this in the editor, it has not been created yet because no instance of this scriptable object has been made. So then we'll create a new one. And then same in decrypt. If it has not been made, we'll create a new one. Okay, maybe that will work. But we're still going to get that error that we cannot access the player prefs while in the editor. But that's fine. We know what's going on there, and I have it on the to-do list to change that to something else. All right, so now if we encrypt, operation not supported on this platform. Wow, so I guess we went down a huge rabbit hole for nothing. Let's see if we can go backwards. That's going to be key. No, that's fine. Then. That's actually still fine. That should be fine. Now the problem is we need to pass in the... I could only go back so far in the history here. Oh, I'm sorry, this should just be key. And then string IV. And we'll add those. You have to pass those in to decrypt. And yes, it could be made static, actually. Now this is going to be a problem. How far back can we go here? Not very far. Let's go look at what the code used to look like here. Back in my tools. Nope. In encryption. No, under core. Encryption settings SO. This was the original. So I don't think I can just Control A on all of that, unfortunately. I guess we could discard this. That should then recreate the object. Encryption settings SO, perfect. And then we can just take all this and we'll put it down into the encryption keys. Now we don't need those context menus because that won't work in here. But we do want the string builder, and we do want the allowed characters, and this is going to be the key, generate random key, and this is going to be the IV, generate random IV. Perfect. That's fine. That's fine. The encryption, let's just say the key and the IV. Key IV. Alright, so encryption keys is a data object for holding encryption keys. Because we cannot do asymmetric. We want to do asymmetric, but asymmetric is not going to work for us here. So get the key and get the IV. It might work, but not on this platform, apparently. So let's go back to the symmetric encryption. Went down a huge rabbit hole for nothing. I hope you're laughing at me, Memo. So... Key has no setter, that's fine, and IV has no setter. We're going to rename that to IV. We're going to rename that to just key. IV. AES. AES. It's actually lowercase. AES encryption key. AES encryption IV. Those will be the keys for those values. Getting confusing here now. All right, so key equals the value that you pass in. And IV will also equal the value that you pass in. We'll change this to get or set the IV, get or set the key. Boom, okay. So then when we first create this object, we actually don't need these to be public, or I mean serialized. Nor do we need this class to be serializable, actually. Then, I guess I could just technically do that. And that. All right. Generate random key, generate random IV, and I think we want this to be a string and that to be a string, and it should just return generate random string, and that should just return generate random string. These can then be made static, and then that way we don't have to pass in the value here. We just call generate random key and generate random IV. All right, so then key and IV. Now, do I ever need to use this? Maybe. We'll just call this, let's make this public, but we'll put it up here. And we'll just call it generate. Generate a random key and IV pair for encryption. Cool. All right, so now we have our encryption keys. That should all work like it did before. Now our AES encryption is where things are going to have a problem. That will be encryption key, that will be IV. Cool, so that should all work. Then string key equals blank and string IV equals blank, and re-add those XML comments, an optional encryption key, and an optional initialization vector. Encrypted string. Now, this one's all correct, but we weren't able to go back far enough in the history here, so let's do that. Let's recreate it, I guess. So using var AES is AES create. That automatically creates a key in IV for us. If not string.isNull or whitespace key, then AES.key equals this, convert from base 64. And just copy and paste that. And if the IV is not blank, then we'll fill that in as well. Then how did we get the bytes? We just want to make this called bytes. Bytes equals encoding dot utf8 dot get bytes of the input. Okay. We don't need that anymore. We actually want to make this an encryptor, and this should be create encryptor, but with that same key in IV. Then this would be called encrypted. Will be the encryptor. Transform the final block of bytes to the bytes.length. And then we return convert to base 64 string the encrypted bytes. Alright, so that's how we had it before. And we'll kind of do that. Just clean up some stuff here. Okay, so that was our original encryption that is symmetric. This was our original decryption that is also symmetric. That all looks correct to me. I'm glad I remembered what this looked like too, because that would suck if I didn't. And then let's go update the interface. And I guess it can't be static because it's from the interface. So this one also can't be static. And let's update the interface to match. And boom. Okay, so our interface is good. Alright, so our AES encryption should be good and working again. And then the encryption SO implements that. So let's just update that how it should be. And then this should be added here, and they should be made empty values because they're optional when encrypting. Then, so that's good, that's good. The encryption settings is not needed because I just copied all that into here, I think. So we can now go ahead and delete that class how we did. And this AES encryption object then needs the string key and IV. And that should be this AES encryption and that AES encryption. These are overwritable, but what we want to do is take the signature from here and put it here. Overwrite it. And same here, take this signature, put it here, and overwrite it. Shoot. The encryption key, the encryption initialization vector. We'll copy those comments and fill them back in here just so everything is matching and up to parity. Boom, okay. And now we should be passing in the key and the IV. Boom. Okay. I think we are back to how we had it before. Actually, hold on. So in here, we should be, instead of using the key that's passed in, we should be using the key from the encryption keys. Gotcha. So we don't even need those if statements. Let's just put that there. That should be the encryption keys .iv. Boom. And then we don't need to pass in a key in IV, because that's how we wanted it. We don't want you to have to pass that in. I could make a version that does, but I would prefer not to. And that way everything lives up inside the encryption keys class that's not publicly accessible. So then now we have to update our interface again. So all that work that we just did to update this, and now we don't need it anymore. That's fine though. This is the better way. This is the way. We gotta go into the encryption SO class. Boom. All right, perfect. So that implements the interface. That doesn't need these values, and everyone's happy. All right, I think we are back to symmetric encryption, and then we can move on from here because I already had it working and there was really no reason to go down that huge rabbit hole. But oh well, it is what it is. Yes, I know that's not going to work. Okay, encryption is a pain in the ass. Let's encrypt that. It gave us back nothing. Shoot, I shouldn't have broken all this. That's too bad. Unstage all that. That's fine. When we create a new encryption keys, so the interface is fine, I know that. When we create a new encryption keys, those should be generated automatically for us, but then we can set them . Sorry guys, I accidentally hit my mic there. I mean, technically this looks correct to me. Oh, by the way, we should make this key equals that and IV equals that. Okay, now it all looks correct to me. then the AES encryption we accidentally got rid of our to-do here. Let's add it back in. To-do, do not use player prefs and encrypt key/IV when saving to device. Dang it, Memo. I had all this working and I frickin' broke it all. Like a dumbass. Okay, so I guess let's add in some log statements here so that we can see what's going on. Debug log. Didn't mean to do that. The encryption key will be encryption keys.key. And encryption IV will be the encryption keys.iv. I already know the input value. We should be getting the bytes. Convert that to base64 string. Is that correct? Should we be getting the string of the... Yeah, I guess so. And I guess just for fun, the bytes is the bytes, and encrypted bytes is now the encrypted bytes. And we should be getting back the string. So let's check that those even exist when we try to encrypt something. I think it might be the issue. And this just uses AES encryption under the hood. I mean, technically, this all looks how it did before, so I'm not sure what's broken here, but I could just put it back to how it was. That might be the whole issue. We do have an encryption key, we do have an encryption IV. But we're not getting anywhere else, so we must be hitting... we got these two log statements, but we're not getting the bytes correctly. This must not be right. I thought that's how I did it originally, though. In fact, we can go check. Let's go check. How did we do it originally? So under core, under AES encryption, that was not right. In fact, we might be hitting an issue here. That's right. Okay, so we're just generating random gibberish for the keys, and that's actually not what we want to do anymore. What we want to do is do it with the AES. So using var AES equals AES.create, return AES dot, no, don't return that, just AES generate key. Well, technically it's already doing that, just return the AES key. And then we want to convert please add the using statement, thank you, to base64 string the key. Boom. Alright, so that might be part of the reason. We're trying to set the key on the AES object to something that we generated ourselves, and it's not the right length. And that is not the right way to do it. And maybe we will even pass in the AES here. AES equals null. If AES equals null, then do the using AES we'll just do that like that. AES equals AES.create. If it's not null, then the key equals this value. Let's actually call this existing AES. So if existing AES equals null, no, if existing AES is not equal to null, just return the existing AES key, but convert it to base64. Okay, I figured it out, almost done. So if it's not null, we return that. Otherwise, we're gonna create a new AES using var AES equals AES.create, and then return convert to base64 string. That way it'll be disposed here, this one that we created. And the existing one we'll put up here, so we'll say using var AES equals AES.create, and we will pass in the existing AES here and here, and then it will automatically be disposed. So same thing down here, and just make sure the parameters match, and make this the IV instead, and that'll be the IV. That way these things randomly, or will dispose of themselves properly, and then so when you call generate on the encryption keys, it will create a new AES object, and will then generate a random key with that AES object, or a random IV with that AES object. You know what? I don't even need to do this. Let's just make a constructor and call generate from it. Oh, wait a minute. I technically need the code from those, though. So we'll say that equals that, and that equals that. Then we can get rid of these and just call generate. So when you create a new encryption keys, it will automatically generate the key in Ivy for you. And I would actually prefer to put these down here as private values and have you just get them that way. And IV equals, oops, IV, and then we actually do that here. And it's still going to tell me I can do that. Well, I guess I'll just do it that way then. Yeah, just with the private setter. That's what I was looking for. I only want this class to be able to set those, I think. No, I don't, actually. I do want them to be publicly settable. Perfect. Okay, so that looks right now. The problem was we were generating random gibberish strings for the old way that I was encrypting things, but AES, when I tried to set that key and IV on the AES object, they were not the right size. It needs to be either 128 or 256 bits, or no, yeah, bits for the size. And that was the issue. We should now technically be back to working. I think I can get rid of all these log statements. I'm pretty positive that was the issue here. Okay, and build. Let's go test and move on from this nonsense that we just wasted so much time on. We knew we would get that. That's fine. That's because we're in the editor. Let's just see if we can encrypt. No, we cannot. Shit. Why can't we encrypt? Well, I guess let's add back all the log statements really quick. And then we'll also debug. We don't need to play, actually. We can just encrypt, I think. Did we not attach it to the right editor? What editor did we attach it to? I'm pretty sure it was this one, right? And then we should be able to call encrypt. And I guess it's not attached to the right editor anymore. That's kind of strange. Let's just close and reopen that really quick. Ooh, I'm sitting horribly. Let me adjust my seat here. Ooh, okay. Let's reopen that project. We've put a breakpoint, and let's let's go ahead and attach it to that project, debug. It might be that this project is not working. Shit. I guess we have to close Unity as well. So let's do that. We'll reopen it. We will reopen the other project or solution. Once this Unity editor has initialized, this is the wrong one. There we go. This is the right one. No longer in debug mode. So if we come here and attach it to the editor, does it know what editor to attach it to? It did. Okay, so enable debugging. And it's now ready. It's working. Cool, cool, cool. That is fine. Go ahead and continue from there. We know that. All right, let's go check out our encryption test. So encrypt. Bro, why is it not hitting the breakpoint? We should be hitting this breakpoint here. We're not even attached to the editor. What the hell happened? All right, attached to that editor. And encrypt. Switch to release mode and switch back maybe. What is going on? Switch to debug mode. Unable to connect to Unity editor. Well, that is frustrating. Just so we stop getting that error, let's go ahead and comment all that out. Hello? What the hell? Comment all of this out. Excuse me. Bro. Oh my god, Writer is pissing me off now. Alright, reopen the project. Let it load for a second. Why can I not comment all that out? What the hell is wrong with you? Alright, comment all that out. Go to the editor. Let's close all the other editors and stuff, because that might be part of the issue. We just want these two open at the moment. And switch back to release mode. Yes, I know. Oh, well, duh. I don't think I ever built the new solution, did I? We got to do that first. That would help. That's why it was not attaching to the editor, because we did not give it the updated libraries. Aha! Okay, so now it has the updated libraries. Now we can attach to the editor, debug, go into Unity, enable debugging for this session, let it recompile the scripts. Awesome, everything is as expected. And if we try to encrypt, we're then going to see that's the key, that's the IV. If we step over that, it set the key properly. It set the IV properly. We then got the byte array successfully. We created an encryptor. We got the encrypted version of it. Here's the encrypted bytes. And we then returned it. So if we go back to the editor, hey, it's working again. All right, now if we decrypt, we should get the same string. Encryption is a pain in the ass. All right, we are back to working. Haha. Well, that was a huge waste of time and totally not worth it at all, but it's okay. It's now working. We can move on. We don't need to worry about that garbage anymore. We can stop debugging. We can put this back into release mode. We're going to have to save our work so that I don't lose anything. We can get rid of this. And let's rebuild the Unity packages for the Dark Matter Studios tools, and we'll pull them into Midnight Sun and see if we can actually create a encrypted save file now. That one's already open. We want Midnight Sun. And now while this is exporting those packages, I'm going to step away for a quick second, guys. Now is a great time to go get some water, take a stretch break. I'm going to run and do the same and use the restroom and stuff. I will be back in a couple minutes. Be right back. Alright guys, I am back. Let's get back into it. We got our packages are now exported. We can go into Midnight Sun. We can import the latest package. And our save system should now work as we expect it to. Hurrah! Yep. I know that. That's fine. It's just load and unload, because I took the time to rename those. Wonderful. Alright, go back here. That fixes all that. Alright, so let's go ahead and start the game. We have our splash screen. Let's go ahead and open the persistent data path, make sure that keeps running in the background. We still have our old save file here. And now we should be able to start a new game. We'll put in memo as the name and start. And we're still hitting that issue where it was unable to back up the save file. However, we did get encrypted data this time. So if we open up the save file here, look at that memo. We have your save data and it is compressed and encrypted. So you cannot cheat at my game anymore. Haha. So that's working as expected. Now the next problem was we are unable to back up the current save file. So let's close all this encryption stuff. I should probably save my work. But let's go look at the save manager really quick. Specifically the file save system. When it is told to back up, I guess backup is two different words. I didn't realize that. I guess the action is backup is one word, but when you refer to it, it has to be two words, is the proper grammatical way to do that. Anyways, that's not the point. So, we want to take, so who's calling this? So in the save manager, yeah, okay. Interesting. Yeah, writer teaches me things like how to spell and how to be grammatically correct. It's another great benefit of JetBrains Writer. So we're getting here and we're trying to back up the current save file. Now, what is going wrong? He's the backup dancer. Gotcha. So as a noun, it's all one word. But then when I refer to it here, the save file to back up as a verb, then it's two words. Gotcha. Interesting. Okay. So verb form is two words. He backed up. Or just, yeah, exactly. Okay. So let's see what's going wrong with the backup here. Gonna add in some logging. Now what? Oh, so if this returns false, the only way it returns false is if we get an exception. So there must be an exception happening here. Whereas saving is working just fine, which is interesting. Now, I wonder if that's because of the hash verification. I'm kind of skipping all that for a backup. But you shouldn't have to do that for a backup. Let's just add some log statements and kind of see what's going on. All right, so serialized backup is then the serialized backup. Then we'll do this. We'll say this is the compressed backup. And then we'll do this. And we'll say this is the encrypted backup. And actually, we could just attach this. We could have just attached this to the other Unity editor and stepped through it. But I'm going to add some log statements really quick to get backup file name should be the file name, but with the backup extension. So that should be just fine. Whoops. So just copy that. And we'll say backup file name should be that. The backup path probably would have been easier to just step through this with a debug statement, but that's fine. And then we're just doing a write with the file system. Should be all we need. Let's just add that. Let's build it. Let's get it into the other project. And then we'll actually just attach it to the code to the editor and step through it, because that'll be easier. We're going to get this figured out. And actually, heads up, I cannot stream for too much longer. I could probably go for another hour, but then I'm doing some family stuff tonight in a little bit, so I'm going to have to cut the stream off. But reminder that tomorrow is the awesome Fortnite Metallica concert, so you definitely don't want to miss that. I will be streaming for that. They have a few different concerts throughout the day. One is at 11 a.m. Pacific time, 2 p.m. Pacific time, and 5 p.m. Pacific time. I don't know if I will be around to do the 11 a.m., but I will be around for the 2 p.m. That is for sure. Okay, what was I doing? Let's export the new packages, and then we can import it and connect to the editor. And we should really probably think about saving my changes off to the repo, because I think I've changed a lot of stuff now. I don't know if you guys can hear that music or not. Turn it up a bit. Exporting packages. And while that exports, I'm going to eat some fruit snacks really quick. I'm kind of hungry. I just realized I should update this file system to also include asynchronous file writing and stuff. That might help with some performance. Alright, packages exported. Let's go ahead and import the full install addressable URP package. Import that. I guess I don't need the full thing, but I'm just used to doing that every time now. Alright, then we should be able to play, and in the console we're going to get some logs. Let's clear that because we don't care about those logs. This is more specifically when we try to create a new game and save. It will set the default location when we create a new game with memo start. Current location did not exist, trying to save, unable to back up. Now, what happened to all the new logging statements that I just added? It didn't even print them. Did I do this right? Well, okay, let's do this. We will come back to that. We just added all these new log. Did I not build these projects? I did. I must have. Well, let's do this then. Let's set the breakpoint. We're gonna attach it to a Unity editor. I don't know that it will allow us to do that. Let's change it to that editor. Hit OK. And let's see if that worked. No, it did not. Like that. It attached it to this editor. That's not what we wanted. There we go. Now it attached it to the other editor. Okay. So attach it to this editor. We will wait for it to recompile for debugging mode. And let's play, and we'll step through it when it tries to create a backup. Now, why is it trying to save right when we start to? Oh, because it's doing it on application pause. Interesting. Well, I have that in there because in Android or iOS, if you like move out of your current application and like open a different application, on application pause is what's called for Android and iOS. So then it's trying to save because the application was paused when we started it, which is weird that it does that. All right, so Bob and start, and oh, I forgot we had this breakpoint there still too. So let's resume the program. All right, so we have our save file named Bob. We have all of this data, including the hash and stuff. And let's step over that. Oh, wow. It couldn't even serialize it. That was the problem, is it could not even serialize it. Now why? Error getting value from name of location SO. Object reference not set to an instance of an object. Interesting. That's not good. I think that's because it actually has the save data in it now. And I was worried this would happen because it's a scriptable object that we're trying to serialize. Can I still look at the save data here? Yeah. So the current location of Sandbox A was in fact added to the save data like we expected it to be. Now the problem is right here when trying to get the name of the location to serialize it, we're getting a null reference exception. We're getting a null reference exception because the scriptable object instance does not exist. I was kind of worried about that because I'm using a scriptable object, that I cannot add a scriptable object to the save, to the save data. Serialize scriptable object unity. Nope, that's not what I wrote. Serialize scriptable object unity. I'm pretty sure scriptable objects are serializable, but maybe I need to double check in my location SO class. Gotcha. So I don't think this is serialized. This is the problem. It's trying to get the name to serialize it, and I don't think it can. And then it's going to work the same way too when we try to load the scriptable object from the save data. It won't be able to load the instance of the scriptable object. Huh. Okay, so I'm pretty sure the problem is because we're trying to save a scriptable data or scriptable object to the save data, and a scriptable object can be serialized, but the problem is, well, there's a few problems. One that I can foresee, and the other problem that it cannot access the name. Or the JSON serializer cannot do that. Now, I can't even add serialized field there, right? Oh, I think I know no, a scriptable object should be serializable by default. So I don't think I have to add serializable here, but maybe I do actually. Let's try it out really quick. Go ahead, debug that. Waiting for it to be ready. Might have screwed up because I was still playing and I didn't realize I was. Oh wow, it's actually trying to do it again. That's funny. So then if we skip over it, yeah, we're still getting that same exception. That the value from name on location SO so I'm thinking I'm gonna need some sort of library that keeps track of all the location scriptable objects. And that way you can pass it a string name value and it will then try to give you back the scriptable object instance of that matches the value you passed it. That way I can do the reverse. of instead of saving the location scriptable object to the save data directly, instead I can just get its key or ID and save the ID to the save data as a string. And then that ID can then be exchanged for the instance of the location scriptable object. Now, the only thing I don't like about that, I guess it'll be fine because I'm using addressables. So I don't think that adding serializable here is going to help in the slightest. I don't think that's the issue. I think the issue is that this is a scriptable object and we're trying to save this object into, we're trying to take this entire scriptable object and serialize it and save it, its instance, into the save data. And that's not actually what we want. I think instead, where are we doing that? So in start, current location key should be the default location dot name. Why isn't that working? That should be fine. So current location equals current save file dot get, like that. Oh, gotcha, because this is expecting. So right here, we need to exchange the current location name for the scriptable object instance. And then we pass in that scriptable object instance right here when we're setting the current location. Ooh. And actually, we don't even need set current location, I don't think. Unless someone else needs to do that. We really just need load and unload. So this is actually a redundant event that we no longer need. We can get rid of that. We can get rid of that. And we can actually just call load location right here. But we have to pass it in, the scriptable object instance. And then we don't need that method. That was all redundant. Now we need to, I guess, in the location manager, we could just make this an array of location scriptable objects, and the very first one, let's call this locations. We don't want the formerly serialized. The location scriptable objects. Then, so we can say locations 0 dot name. And then here, current location name. And then here we would say var current location equals locations dot first or default, where x dot name equals current location name. if current location equals null, so maybe instead I have the location manager hold all of the scriptable objects, and when things need to load a location, they just pass in the name of it. Possibly. I'll think about that. So if current location equals null, debug dot log error from the location manager. Location manager has no locations, and return. And then last but not least, we'd load the current location. All right, that should technically fix our problem. And then that way, we're not adding the scriptable object instance to the save data. We're just adding the string name of it, which is like the key of that location, right? Yeah, that should be correct. Oh, they're doing the member royale over at Toby's channel right now. Maybe I'll join that. Refreshing in the editor. Am I still debugging? I am. Let's stop debugging. Go back to the editor. Go back to the editor, please. Thank you. And now, let's do it like this. Let's open the persistent data. Let's delete all these save files. And just for the fun of it, so we can see what's going on, let's disable compression and encryption for the moment. In fact, I want to try something. I'm curious why this prefab variant, when I change the variant, why is it changing the original? I don't like that. Let's delete the variant. Let's recreate it. So create prefab variant. We will put that variant into the persistent managers folder. We can remove the name variant. We know that it's a variant because of the icon. And shit. On the original, let's check those. And then on the variant, it then has that. And if we uncheck those on the variant should not have them, but the original should. That's so weird why it's doing that. Anyways, that doesn't matter. I just wanted to see if that would fix it really quick. Now, what is this? No location found for this key. What? What are you talking about? Splash scene SO. That has everything. That's the only thing that should be being loaded. Oh. We forgot something. We got to go to the loading manager. I'm sorry, not the loading, the location manager. And he now doesn't have any locations. We need to give him that sandbox A location. Boom. All right, save, back out. I don't know that that was the problem I just got, but maybe it is. We'll see. Now, who the frick is trying to call? So the startup configuration, startup profile, is initializing the persistent managers, and so one of them is null. Gotcha. So we just forgot to add back the save manager variant in there. That's why it's yelling at me. Okay, try that again. Play. We should have no more errors. Everything's working as expected. And we have no saves at the moment. We should be able to start a new game. Compression and encryption are turned off. So we should start a new game. It will see that there is no current location for the game. And it will then add that to the save file. So let's start a new game for Memo. Hit start, and interesting. So that wasn't even the issue. We're trying to get the name value from the scene asset. I'd be willing to bet that the asset is what's null, because we have not loaded the asset. So maybe we set the name inside the location scriptable object. But that seems to be the problem, and it's not even that we need the location so we could have probably saved just the... No, because we're still going to have an issue when we try to load that scriptable object, right? We're still going to have an issue regardless. So it does need to be the name, but the location scriptable object, instead of getting the name from the asset, most likely the asset is null because all we have is an asset reference, and we have not actually loaded the asset itself. Can we just get the name from the reference? Sub-object name. What is that? That might be what we're looking for instead, actually. I'm curious. Asset reference sub-object name. Reference to an addressable asset. That's not what I'm looking for. The stores the name of the sub-object. Interesting. So that might have been what we needed, actually. Is instead of trying to get it from the asset, we can get it from the stored sub-object name. Because the asset itself has not been loaded, all we have is the asset reference, because we're using the addressables system. Let's give that a try. Yeah. Alright, trying again. We'll start it back up here. Let's make the console a little bit bigger so we can see any errors that happen. We don't really need the stack trace, we just need the console itself. Alright, we start new game for Bob. Hey, that worked. We got the serialized backup. And then it saw that the data on the current save file was dirty. Yeah, Bob the goat. Woo! It saw that the data was dirty, and it did save it successfully. So now if we go in here, unfortunately, Memo, we know that your save files are broken, but we'll create a new one for you in a second. And now we can look, well, now here's a problem. It added the current location, but that sub-object name was just an empty string. So it did not give us what we needed, but it did fix the problem, technically. Interesting. So I think I have to do it like this then. I think we're going to have to go into the location scriptable object. I think we need to create a new serialized field. We're going to make it a string. We're going to call it name. We're going to say it's the location's name. and then we're going to reference that here so that when we try to get this value, it will be the string that we've given the scriptable object. I thought I could just read it directly from the asset itself, but I guess that's not the case. Maybe there's a way to do that, but for now, we're going to go with this workaround. So if we go to the sandbox A location, we will then call this sandbox A. There's got to be a way to read the name of the actual asset without having to load it, I would think. But I guess with the addressable system, you would have to load it. Anyways, we filled that in. Now let's start a new game. We'll create a new save file for Memo, and that current location, let's delete Bob's save file. Bob is no longer the goat. Memo is the goat. And when we create a new game for Memo, it should then, in fact, have that current location set as Sandbox A. So new game for Memo, hit start, everything worked, it saved, it even created a backup. And if we go in here and we look at the save file, perfect, there it is. We now have the player's current location saved to the save file, which means the next time that we play, we can load the player back at the last known location, right? The current location. Yeah. Cool. Okay, we made some progress. Now, here is the next problem, is that when we play, when we get to the start game screen, crap, did I actually just delete your save file? No, I didn't. Okay, so there's your save file, and there's even the backup of your save file. Ooh, how about that? Pretty cool. And it's just the same thing, but just with the BAK extension. So, and the reason I do that is when I try to save, I first create a backup of the original save file. That's the backup. And then we try to save the new save file. And if anything goes wrong, we take the backup and we basically just remove the extension and put it back as the original. And then say, hey, saving did not work. But here's the next problem. When we go to this start screen, we should have an existing profile here for Memo that we can then click on to load an existing game instead of starting a new game every time. And that does not seem to be working as expected. So here's what we're gonna do. To test this in the fastest way possible, let's create a new mono behavior called save files test. Save files test. And then in here, have a serialized field for the save manager. Actually, I don't think we need to do that. Serialized field, a list of save file. Save files. And we can actually do another one that's just not a list and say this is the current save file. Now, the save manager should already have all the save files. So what we're going to do is in the start method, the current save file equals savefile.current, and save files equals savefile.all. So I made some nice little static members properties of the save file class where those are set. And the reason I'm creating this little test script is because I can then throw this into the main menu scene. This was the fastest way I could think to test this. Save file test. And we'll throw that script on there, reset its transform. I really wish Unity would create empty scriptable objects already zeroed out for you, but that's for another day, I guess. Oh, interesting. Are these not serializable? Well, shit, maybe they're not serializable, and this little quick way to test is not going to work anyway. No, they should totally be serializable. Why aren't you serializing them, Unity? What is your deal? That's okay. What I'm looking for is, let's clear that list. When we get to the main menu, this object will try to fill in those values with the save files that we have. We should have, in the list of save files, one instance show up for Memo's save file. And if it does not show up, then those static values under the save file class are just not being set correctly. And that would be the issue. So let's go ahead and start. So right here, the save manager has been created. It should be checking the save directory, finding anything with the .save extension, and then adding it to that static property. So now when we get to the main menu in the next scene here, boom, main menu, we should be able to go to this save file test, and no save files showed up. So I guess they're just not being set, possibly. Let's see, when are we doing that? We're doing that in Awake. Save file all should be loading the save files. So I guess let's go down into our file save system. I'm also curious why the save file is not showing up in the inspector when it's just a regular C# class that's serializable. But that's kind of a different problem, I guess. We got backup working. Before I change anything, though, I want to be able to break line through this. So we want to go to the load save files of the file save system. Now in here, we're creating a new list. If the save directory does not exist, we create the directory and then we just return the new empty list. If it does exist, we are getting the directory info from the file system. We are then getting the file info of all files inside of that directory. So this is a list of file info. And then we're iterating through that list of files and saying for each file, try to parse the save file to get back, or try to parse the file to see, is it a save file? So let's put a breakpoint there. And let's go in here to the try parse method. I have a feeling somewhere in here is breaking. If a file does not exist at the path, maybe I'm passing in the wrong path. That's possible. So let's breakpoint there. Then we're blah, blah, blah. We're reading the file to get the contents of the file as a string. If the settings to use encryption are turned on, I was going to say impression, like encryption and compression combined. If we're using impression, then we decrypt and decompress. New word that I just created. So let's start over. So we read the file from the path to get the contents. If encryption is turned on, then we decrypt the contents. If compression is turned on, then we decompress the unencrypted. No, well, it might not be encrypted. Then we decompress the contents. And then we try to create a save file by deserializing the contents. Technically that should work. I don't see anything wrong here. Yeah, I know, right? Banging my head against the wall again. And we'll get into the hash verification stuff in just a second. But we have it breakpointed. Let's attach it to the editor. Let's go back in. I don't think it attached it to the right editor again. It should be that one, please. Apply, okay. Stop and reattach it. Waiting for target. I mean, technically that should have worked. I think it's doing that thing where it's not going to work again. Let's close the editor. Let's unattach this. It would be so nice if some of these little things wouldn't get in my way, because they become super big speed bumps that are quite frustrating. Let's close that. Let's close this project for now. We'll come back to it. I've only got about 15 more minutes here, and then I'm gonna have to jump off and go get ready for the family stuff I'm doing tonight. So hopefully we can get this figured out. Let's go ahead and close that too, just because. Reopen Midnight Sun. We got this. All right. Now reopen the Dark Matter Studios tools solution. I'll just call it the Dark Matter Studios solution. Reopen that. We've breakpointed. Let's go ahead and attach it to the Midnight Sun project. Enable debugging. Now, technically, this should be happening immediately. So right when we press play, we're going to hit the breakpoint. So we did, in fact, find Memo's save file. Okay. So that's not the problem. What is the full name? That is correct. That is where that file lives on my computer, in the persistent data path under the saves directory, and that is the correct file name. So now let's continue. We should now get to this next one. If the path does not exist, we're returning false. We should skip over that, which we do. So we're now reading the contents of the path. We have the contents as a string. We are not using encryption. That's right. We are not using compression. That's right. Now right here, we have the JSON representation of that class. We should be able to deserialize it successfully. We did. We deserialized it successfully. If it's not equal to null, or if it is equal to null, we return false. So something might be going wrong with the hash verification. So we have hash verification on, and what that checks is technically I could save the file without any encryption or compression, which we've done. It's in a readable format, right? It's in this JSON format, and we can read it as plain text. Now, what the hash does is it takes whatever's in there and it creates a hash and adds it in and then writes it to disk. Now, if you were to make any changes whatsoever to this data to try to cheat or whatever, when it tries to rehash, that hash would not be the same, and it would know that you tried to make a change that you shouldn't have. So let's see what's going on. So interesting. How did we get from here with the hash, or when it deserialized it, we have the hash, but when it deserialized it, did it not set the hash? Is that the problem? It should have. It should have deserialized the hash properly. It looks like maybe it did not. So when we're deserializing the save file, the existing hash is actually being set to null. That's interesting. Why would it do that? It was able to deserialize everything else. This is just a string, just like the GUID. Why would it not deserialize that? But that seems to be the problem, is that we're grabbing that original hash, we're then setting it to empty, we're re-serializing the save file and creating a hash from that serialized save file. And if this hash that we create here matches the original hash, then we say everything's good because you haven't made any changes to the save file. If everything is not good, we set the save file to null and we return false. But clearly something's going wrong with the deserialization of the hash. So I don't even need to go through the rest of this. I already know that this is not working. So it's been set to an empty string. We try to re-serialize it. We get a new hash. Here's the new hash. But the original hash is null because it wasn't able to deserialize it. Also, this hash does not match the hash that we had in there. If we go look at the original hash, it should start with 56DB. This one starts with CEE09. So something's going wrong with the hash verification, and that is why we're not able to load any current files. Okay, so let's stop running. I understand what the problem is. This might have to be a problem for another day, though. So we got backup working. Loading existing files is not actually the problem. It is hash verification. And I'm writing into thin air again, I know, because I'm on my green screen. But that's okay. You now know that there's a whiteboard there. Now, funny enough, if we go to the Save Manager prefab and we turn off hash verification, we say we don't care if the file matches or not. So if I play with that turned off, technically we should get Memo's existing save file showing up as expected. All right, we'll press start. Hey, yeah, we actually now have something there. I don't think I'm actually filling in any data on this object, or for the UI, that is, but it did in fact recognize it. Yeah, nice. And then in fact, if we go to this save files test, yeah, there we go. There, oh, it even filled it in with the name. So we do have Memo's save file now showing up. The problem is now the hash verification. So we're very, very close. We've actually gone through 90% of the rest of the save system. The last piece here is the hash verification. Saving and backing up is actually all working how we expect it to now. We just cannot load an existing file while hash verification is turned on, because for some reason it's not deserializing that correctly. Now, why it's not, I'm not understanding, because it deserialized everything else just fine, and all that is just a string. We even have an internal set so that we can set the hash if we need to. Well, this is probably going to be another complicated problem to go read through, and I don't know that I have enough time today to do that. So maybe what I'll do is I'll get on a little early tomorrow. We will try to figure out this hash verification. And with that, our save system will be fully working as expected with hash verification, compression, and encryption, and automatically create save files and load save files for you. And we can then just read or from those save files or add to the save data inside of those save files. So we're like 90% of the way there. And then we'll even fill in the UI for the existing profiles that show up. So that way it'll actually show the name of the profile, your last location, stuff like that. Now, with the last 5 minutes that I have here, let me try to figure out what is going wrong. I don't understand why it wouldn't be able to fill this in. It's just a string. We have the string ID, the string GUID, the string version, the string for the created date time, the string for the last modified date time. All of those deserialized successfully. But the string for the hash did not? Actually, what I should have checked too is, did the save data deserialize successfully? That's another important problem. Let's go check that really quick. Because if everything else to here deserialized successfully, and then it got to the save data, and it wasn't able to deserialize this, that would maybe explain why it wasn't able to deserialize this hash, because maybe it hit an internal error on this and just returned the object as it was. I don't know if that made sense or not. I don't even know if that makes sense in my own head. Let's see. Let's play. We should immediately get here. We can skip over that. Skip over that, skip over that, skip over that. All right, so here's our contents. We have the ID, the GUID, the version, if the file was auto-saved or not, the created date time, the last modified date time, the number of times it's been saved, your save data, which includes your current location at the moment, but will also include other things like your level, your current health, your current magic, I don't know, whatever else we throw in there, and then has a hash. Maybe the hash should actually go up here above the save data. That's not important. So we have the contents correctly. The save file's currently null because we're on that line as we speak. And if we skip over it and we go into the save file, sure enough, the hash is null, but the save data is not. It has the save data for the current location of Sandbox A. So why isn't it able to deserialize the hash? I'm not understanding why it wouldn't be able to do that. It's just a string like all those other values. Come on, think. Why would you not be it can serialize a save file with a hash and write it to disk, but it can't deserialize the same serialized thing that it spit out? I don't know that that makes sense to me. Everything else deserializes as it should. The hash is the only thing that does not. And sure enough, it is in here. And everything else before it deserializes correctly. All it is a string of random characters, but it cannot deserialize it. I am not understanding that. Unless something in the serialization settings we should just be giving it the input string and getting back the object that we specify, which is working, but for some reason it's not setting the hash. Interesting. I'm stumped by that. That's very confusing, because when we give it the object, the save file object to begin with, it does in fact serialize it as we would expect. I wonder if because I'm passing in the formatting that's the problem? Maybe we don't pass in the formatting or the JSON serializer settings. Either way, I'm going over my time here. We now know where the problem is, we just don't quite know how to solve it at this moment. We do have a workaround, though, is we can disable hash verification, because that's not super important, especially since we got encryption working. It's just a feature that I wanted to have in the save system anyways, but it could be figured out another day. So we have it written down on our to-do list. That will be, I guess, the next thing that we look at. And we will time box that as well. So if we cannot figure out still what's going wrong with the deserialization, then we will just leave hash verification off for the time being until at a later point when we can figure it out. But we actually made some good progress today. We now have save files fully working. They can compress and they can serialize, compress, and encrypt. And then we can also load existing save files and show them on the start game screen, all with the exception of hash verification. So yeah, we actually did really good today. It was kind of a lot of going down a rabbit hole after rabbit hole. But I think we're getting to a better point in the Unity editor, or in the project. Here, let's go ahead and watch this one more time. We are now getting to a better point in the project where we could start a new game or load an existing game, and it will remember all of your saved data, which is very important. So I guess let's see. Now that we have this working, we have to make it so you can click on this existing profile. The profile should be renamed Memo, because that's the name that we have, is Memo, or whatever the save file's name is, that is. They shouldn't all be called Memo. And we need to make it so you can click on it to then load an existing game. And it should then use the data from that save file to... Oh, and I know why it's not showing up here. I just realized, because I have all of these marked as hide in the inspector, which I probably don't need. I think I tried to do that for security reasons. We can probably remove that. That way we can actually see the save file data in editor time. So we'll mess around with that next time too. But yeah, so the goal for next time, let's figure out, let's try to figure out hash verification. Let's set up the UI for these existing profiles. Make sure that you can click it to load into the existing game of that profile or save file. And get back to the game scene at whatever location that you were last at. Once we have all that working, we can actually get a player object in that you could then move around and go to a different save point. And when you hit that save point, it would then save your game with that new save point. We can then stop playing, start again, load the existing profile, and it should then put the player back at the last saved point. And yeah, that will be a wonderful game loop to have. So cool. Making really good progress on this, actually. It feels like I'm banging my head against a wall most of the time through the stream. But I need to remember that I guess, how do I want to say this? What am I trying to say? I need to remember that even this little bit of progress that we made is very significant, and it has lots of value to the game. And that is something in and of itself. So even though I banged my head against the wall most of the day, we're still making progress. And slowly but steady progress. And that's what's important, is we always want to make progress towards the final outcome of this prototype or vertical slice, whatever you want to call it. Yeah. Let me quit that. That's all working. Anyways, I've gone already a couple minutes past when I was planning to get off. I need to go get ready for a family event. So I appreciate all of you for joining in today. Memo, thanks for all your help. I hope, wish you the best of luck figuring out your bug. And in fact, you better be off work now. Go take a break. You got the weekend ahead of you. And don't forget, tomorrow is the Fortnite Metallica concert, virtual concert. We will be streaming and checking that out. Oh, good job. You fixed it. Yeah, dope. Congratulations. Now you can go have a great relaxing weekend without that keeping you up at night. Remember, check out the stream tomorrow. We're going to check out that Metallica concert. Maybe we'll even play some guitar afterwards. And we'll also try to look at the next steps here that we've written down for the progress in this game. And on that note, I appreciate all of you guys. Thank you so much. Hope you have a great rest of your day. And I will catch you guys tomorrow. Peace.